Hello everybody, welcome to lesson 8. We're going to be learning about exponential growth and decay. So the model for exponential growth is A times 1 plus R over 100 to the T. So A represents the initial amount. R represents the percent rate of increase. And T represents time. The model for exponential decay is A times 1 minus R over 100 to the T, where A is the initial amount, T is still the time, and R is the percent rate of decrease. When there is an exponential increase or decrease every m years, the model becomes, so let's take exponential increase, for example. The model will become A times 1 plus R over 100 to the, it's every m years, so we go X over m. A half-life of X minutes represents a decrease of 50% of a substance in X minutes. Let's try some examples. The number of people in the Republican Party was 600,000 in 1940 and increased by 12% every year past 1940. Write an equation that represents the number of people in the Republican Party T years after 1940. So this is just simple exponential growth. A times 1 plus R over 100 to the T. A, the initial amount, is 600,000. 1 plus R over 100. So we have 1 plus 12 over 100. 12 over 100 is 0.12, plus 1 is 1.12. This is similar to the of rule, the greater than rule, and the less than rule that we learned in or specifically the greater than rule that we learned in lesson 2. So this is going to be 1.12 to the T, because it's T years after 1940. How many people were in the Republican Party in 1967? Well, how many years past 1940 is that? That's 27 years past 1940. So we just plug in T, 27 for T. Now, using our calculator, we could get an approximate value for this. It's going to be 127,94928 is our approximate value. A savings account starts with $40,000 and grows by 2% every month. Write an equation for the amount of money in the account T months after it's opened. Well, the initial value is 40,000. The rate of increase is 2%. So 1 plus 2 over 100 is 1 plus 0.02, or 1.02 to the T. How much money was in the account 3 months after the account opened? Well, we just plug in 3 for T. Using our calculator, we got 42,448.32. The amount of money in a savings account decreased by 1% every hour. If there was initially $1,400 in the account, what is the equation for the amount of money in the account after X hours? So the initial value is 1,400. The rate of decrease is 1%. And we will find every X after X hours. So we have 1,400. The rate of increase, we plug in to our formula 1 over R, 1 minus R over 100 to the X, when R is just 1. So it's 1 minus 0.01, or just 0.99. How much money is in the account after 10 hours? So we plug in 10 for X. Using our calculator, we get 1266. Currently, the population of a small town is 800. A statistician estimates that the population of the town will decrease by 5% per year for the next 6 years. The statistician models the equation P of the population P of the town after X years using the equation P equals 800 times K to the X. What value should be used for K? Well, we know it's going to decline by 5% per year. So in the bubble, it should be 1 minus percent over 100, or 1 minus 0.05 or 0.95. What will the population of the town be after 2 years? Well, this is in terms of X years, so we could just plug in 2 for X. So 800 times 0.95 to the 2, or to the second power. Using our calculator, we get 722 people. A population analyzer estimates that in 2 years, the population will be 73% of its current population. How much less does this analyzer estimate the population to be in 2 years than the statistician? Well, in 2 years, this person estimates that it will be that the population will be 73% of its current population, 800. So 73% of 800, well, that's just using the of rule. So percent divided by 100 is 0.73 times 800, the amount. We get 584. So how much more does the statistician expect the population to be, rather than compared to the population analyzer? Well, that's 722 minus the 584, which is 138 people. The half-life of carbon-14 is 5,730 years. If a container had 400 grams of carbon in the year 2000 and is left untouched, what is an equation that represents the amount of carbon in the container X years past 2000? Well, it had 400. We know that the equation to model this is A times 1 plus R over 100 to the X over, I'm going to say, half-life, because it's every 5,730 years. So the A value is 400. Inside the bubble, it says half-life, a decrease of 50%. So that's going to be 0.5. It's actually going to be 1 minus percent over 100 because it's exponential decay. To the X over half-life. The population of bacteria in a lab experiment doubles every 2 minutes. There were 70,000 bacterium at the beginning of the experiment. What is the equation that represents the amount of bacteria in the lab m minutes past the beginning of the experiment? Well, that's exponential growth, which is A times 1 plus R over 100 to the t, but it doubles every 2 minutes, so it's going to be to the t over 2. But it's also m minutes, so it's not going to be t anymore, it's m. The A value is 70,000. It says it doubles every 2 minutes, and another way of saying doubling is to multiply by 2. And this is every 2 minutes, so we have to the m over 2. That's it. Hope you learned.